Welcome to qnawire.
Hi, so for this question, we're given already what are the concentrations of at equilibrium for a weak acid in aqueous media that is going to produce H2O plus in aqueous media plus a portion of A minus, the conjugate base in aqueous media. So we're told that at equilibrium, we're going to have a certain quantities, 1.91 times 10 to the minus 2 minus x. Whether it doesn't matter, we're going to have x of H2O plus, and we're going to have 1.42 times 10 to the minus 2 plus x of A minus, because we initially had a certain portion of A minus into my solution. So we are required to find the quadratic expression that comes from this and to find the values for x, and the final pH. Okay, so first of all, let's write down our definition for Ka. Ka is equal to the concentration of H2O plus times the concentration of A minus divided by the concentration of HA. This becomes, replacing the values, x times 1.42 times 10 to the minus 2 plus x divided by 1.9 times 10 to the minus 2 minus x. And we are told that the Ka for this weak acid is equal to 9.23 times 10 to the minus 6. And since this asks you to get both of the roots for x, I'm assuming that you cannot make any approximations in order to get the result. So we're going to go ahead and derive the full equation just looking at this section over here. So on the left hand side, we're going to get x squared plus 1.42 times 10 to the minus 2x. And this is going to be equal to the value for Ka multiplied by the denominator. So 9.23 times 10 to the minus 6 times 1.9 times 10 to the minus 2 minus 9.23 times 10 to the minus 6 times x. Now we put together all of the terms that have things in common. So this becomes x squared plus 1.42 times 10 to the minus 2 plus this element goes to the left hand side as a positive plus 9.23 times 10 to the minus 6. All of this multiplied by x minus 9.23 times 10 to the minus 6 times 1.9 times 10 to the minus 2. And this needs to be equal to 0. Okay, so now just doing the arithmetic of these equations, we get, first of all, x squared plus 1.420923 times 10 to the minus 2 x minus 1.76283 times 10 to the minus 7. Here this is 1.91 and also 1.91 here. I just verified the value. Okay, and this needs to be equal to 0. So that means that A is equal to 1, B is equal to 1.420923 times 10 to the minus 2, and C is equal to 1 minus 1.76293 times 10 to the minus 7. With this, solving the quadratic expression, the values for x1 and x2 are x1 is going to be a negative value, minus 0.0142216, and x2 is equal to 1.23961 times 10 to the minus 5. So, with both of those roots, let's verify what x should mean. X should be the concentration of H2O plus. So the value that we're going to get is the value for x2, the concentration of H2O plus is 1.23961 times 10 to the minus 5 molar, giving us a pH that is minus the logarithm of that concentration of 4.907. And that is going to be our final pH of our solution. Thank you very much.